Good morning to all. And let's continue on our topic, which was factors and multiples. Firstly, let's start talking about the factors with the factor tree method or the prime factorization. Factor tree. Now what is this? So in the factor tree, what happens that we calculate the prime factorization of a number. So let's take for example 36. Firstly, 36. What you have to do in the factor tree? You have to break a number many times. At the last, you should have the prime numbers. What I mean that you have to break a number as possible as you can, and at the last, if you have a prime numbers, you can't break it ahead, lifting that prime number into 1. So prime number into 1 is just, it carries no value. So we stop this method when we are reached at the prime numbers. Let's talk about this 36. So the 36 is represented as a product of the 6 into 6 or 4 into 9. You will ask, will I get the same answer? Of course we will get. Let me tell you. But first let's take here 4 into 9 here. So 4 into 9. 4 into 9 gives me 36, and then 4 can be broken down as 2 into 2, and over here also 2 into 2. Then over here 9. 9 can be broken down as 3 into 3. 3 into 3. Now can I break down this 2 or a 3? No, of course not. These both are the prime numbers. And I can't break down these further other than into 1. Now, here, if the numbers which I get at the last is called the leaf node. They had gotten a special name. They are called the leaf nodes. That because, you know, in the tree, at the last of the branch, you get the leaves and you can't go ahead of the leaves. So here, these are called the leaf nodes. You can learn like this also. That they are called the leaf nodes. Now, you can see that I had reached at the leaf nodes and I can't go ahead of this. Now what is the prime factorization of 36 over here? It is 2 into 2 into 3 into 3. So that is the prime factorization of 36. Now let's move ahead. Let's talk about the 6 into 6. Will I get the same answer? So let's take here that one also. So if I will go through the 6 into 6, so 6 is broken down as 3 into 2. So 3 into 2, and over here also 3 into 2, which gives me 6. Now here I can't break down again this 3 and 2 both because they are the prime number. So have I reached the leaf nodes? Of course yes. Now what is the prime factorization in this? It is 3 into 2 into 3 into 2. Now is it similar or is it same with this one? The previous one which we had calculated the prime factorization, this? Of course yes. Only the order is changed of the multiplication over here. And you know that if I will change the order of the multiplication, or 3 into 2 gives me 6, or 2 into 3 also gives me 6, the product will be the same. So this all, if I will multiply, I will get here 36. This is the same as this one. That means I will get the same answer if I will use any way. What I have to do? I have to just break down the number into any way that you find simple in that, easier in that. Let's talk about the... But wait, I think you have a question. We have talked about the two methods here. Factor tree method and also one which we had talked previously about the prime factorization. So, if I will get a same answer in these both methods, let's try it one more. So, here I have gotten this answer. Now, if I will use my previous method, which was like this, we have to divide it. So, let's take this one here. So firstly 36 get divides with the 2, lefting me at 18. Then 18 again divides with 2 and lefting me at 9. Then the 9 don't goes in the 9 don't goes into 2, so it will goes with the 3. Here it lefts me at 3. Now 3 is divided by the 3 and it will give me 1 over here. So what is the prime factorization? The prime factorization of 36 in this method is this one. 2 into 2 into 3 into 3. Is it same? Of course. So I think that this is clear. If you will use any method, you will get any method of prime factorization, you will get the same answer. So let's talk about the multiples. Firstly, what are the multiples? You know that the multiples of a number is just a number which comes in that numbers, but the table of that number. Now, let me explain you in the simple words. A multiple is just a number that gets divided with a particular number. Let me take. Like, take the example of 32 over here. So, 32, can I say that 32 is a multiple of 2? Of course, I can say that's because 32 is coming in the table of the 2, or 32 gets divided with this 2. So, here 32 is just a multiple of 2. Now, is 2 a factor of 32? Of course, yes, because 2 divides this 32 exactly. So, 2 is a factor of 32. Can you see the relationship over here? The multiples and factor, the relationship of that. Let's talk about the multiples, more about the multiples. Let's talk about the LCM. Now you will ask, what is this LCM? So, this LCM is the lowest common multiple. It is the lowest common multiple. And also, some people say that it is least. You can also say that it is the least common multiple or the lowest common multiple. These both means the same. Now, what does it mean? So for understanding this, what is the LCM? Let's take an example of something like take 36 and 48. Now, I have here the example of 36 and 48. Now, what is the lowest common multiple? The lowest common multiple is just a common multiple which is the least one. The least one. Let me tell you. Firstly, let's forget about the lowest and least. Here, the common multiple. Now, a common multiple. Do you understand this word? Common multiple. A multiple which is common in these both, or a number which is occurring in these both tables. So, here, if we had take that we had found so many multiples, so many common multiples in these both table. Now, you have to find the least one, the smallest one, or the lowest one. So, that will be called the least common multiple of 36 and 48. And now, let's try to find the multiple, the lowest common multiple of this 36 and 48. How to find the lowest common multiple? Let's find out. So, if I will take the 36 over here and 48 over here. Now, what I have to do here, I have to first take all the prime, I have to take the prime factorization of this 36 and 48. Now we had learned how to find the prime factorization with the factor tree method or the previous method that we had talked in our previous video. So let's use here the factor tree method. So for finding the the prime factorization of 36 at the last, what we get? We get 2 into 2 into 3 into 3. This was the prime factorization of 36. And over here, 48. How to find that? Let's check. So 48 over here, factor tree method we are using here, the factor tree method. Now, 48 can be broken down as 5 into 8. 6 into 8. 6 into 8. Then 6 can be broken down as 3 into 2. So, here will be 3 and here will be 2. Then 8 can be broken down as 4 into 2. Now here, have I reached the leaf nodes? No. Here is a composite number 4. I can break it down as 2 into 2. Now have I reached the leaf nodes over here? Yes. So what is the prime factorization of 48? The prime factorization of 48 is 3 into 2, then 3 into 2, then into 2 into 2 into 2. So that is what the prime factorization of 48 over here. Then what we have to do next, we have, now here you can see that the prime factorization, the prime factor, the common prime factor in these both is 3 and 2. So, can I say that here if I will multiply this, no, let me explain. Firstly, in this, the prime factors, the common prime factor is 3 and 2. Now, let's take the 2 here. So, in these both, 2 are occurring, and here you can see that in the 48, 2 is occurring here 1, 2, 3, 4 times, and over here it is occurring 2 times. So, I will take the larger one. So here in the 48 it is occurring 4 times, so I will take that one. So we have to find the least one. Yeah. So here the LCM will be here 2 into 2 into 2 into 2. 4 times over here. Then you can see that 3, in which the 3 is occurring more time. In the 36, 3 is occurring here twice and here only 1 time. So let's take this one. Into 3 into 3. Now if I will multiply this whole, I will get the LCM of this 36 and 48. LCM of 36 and 48. Now, what is the LCM over here? The LCM over here, you can see that it is 144. Like here, you can see that 2 into 2 gives me 4. Then 2 into 2 again gives me 4. 4 into 4 gives me 16 and 16. 3 into 3 gives me 9 and then 16 into 9 gives me 144. So it is 144. So that's what a LCM of 36 and 48. But wait here. It will take us so much time. I have to first use a prime factorization and then I have to calculate like this and I have to do like this. So, is there any shorter trick like the HCF we had talked? Of course that is. And it is similar to the HCF. Let's talk about that. Now here, you can see in that first we have to write like this, and here we have to write like we were calculating the LCM of 36 and 48. So 36 over here and 48 over here. Now these both gets divided. We have to first find the common factor. Common prime factors. Here you can see that it is 2. Now 2 gets divides in this both, leaving me over here as 18 and over here as 19. Sorry, I had written here 19. (24). Then again it gets divides with the 2. So here I will get over here 9 and here I will get 12. Then I can move with 3. Yeah, of course I can't go with 2 here because 2 don't divides this 9. So let's go with the 3. Now 3 divides this 9 as 3 into 3 gives me 9 and 3 into 4 gives me 12. Then wait a minute. This 3 is a prime number. And now I have no number, no common factor of these both numbers. So what I will do here, if I was calculating the HCF, we have to stop over here also. But here we are calculating the LCM, and in that we have to go ahead again. If there is 2 number and any number which divide this one number, we will take that number. Like here is 3 and 4. So let's take 2 here. 2, I know that 2 don't divides this 3, but we will go with the 2 here because you can see that here 2 divides one number. You can see here this is 4. Or you can also go with the 3 here. You can take 2 or 3 here. So 2, I will bring this 3 down at the same because here the 2 don't divide this 3. But I will divide this 2 into 2, 4. Now I have 3 and 2. Let's take 2 again. So I am left with 3 and 1. Then I will take here 3 and like this is my, like this. Now it is end. When we had in the LCM, we have to reach to the 1. And then Now here you can see that I had ended with the 1. So now that is the end. What is the prime factorization? No, the prime factorization. What is the LCM? The LCM will be equal to the LCM of 36 and 48 will be equal to of 36 and 48 is equal to 2 into 2 into 3 into 2 into 2 into 3. 2 into 2 into 3 into 2 into 2 into 3. Now that will be my LCM of 36 and 48. Now here see. 2 into 2 you can also multiply this whole. 2 into 2 gives me 4. Then 4 into 3 gives me 12. And then 12 into 2 gives me 24. And then 3 into 2 gives me 6. And 24 into 6 gives me 144. So my answer is again 144. Which was same as the previous one. So that's how we calculate the LCM. Here you can see that. Now I think that LCM and HCF is clear to you. So let's end this video over here, and thank you for watching this video. And if you had find any mistake, or if you had find any if you want any improvement in me, so please comment it in the comment box. Now thank you for watching this video and have a cheerful day ahead.